Yes, good afternoon, friends, and welcome once again to my channel. We will start with Maxwell Boltzmann distribution. And someone was asking whether Vikas Divyakirti sir's videos can be used for the examination purpose or not. So yes, the Drishti IAS Vikas Divyakirti sir, he teaches very nicely, and everything he teaches very in a very deep manner. In very deep manner he teaches. But the problem is that only problem is that he tries to he cannot be political, right? He is a famous teacher. He is a famous teacher, and if he tries to explain the real life situation, then everyone will call him anti-Hindu or anti-BJP or anti-national or something like that. So instead of speaking the truth, he tries to maintain the political neutral tone. Okay, so many times he cannot speak the truth. For example, in the case of CA NRC, he has made a video on CA NRC, right? So in that particular video, he did not talk about this thing that the CA NRC could have been misused. Okay, the CA NRC can be misused in order to take away the citizenship of minorities. Okay, CA NRC, the CA NRC which the Modi government brought, it can be used to take away the citizenship of the minorities. So minorities are at risk because of CA NRC. So he does not tell that in his video. Instead, he tries to say that there is no need to be afraid. But in fact, it is a matter of worry because CA NRC will ultimately lead to the taking away of citizenship of the minorities. So such things are there which he does not discuss in order to remain polite or something. He will never discuss while discussing the Article 370. He never told us. He never told that while discussing the Article 370, he did not say about religious polarization associated with Article 370, because if you look at Article 370, then the Kashmir area is a Muslim dominated area, and if you are removing Article 370 from Muslim dominated area, it implies that you are suppressing the Muslims, and as you are suppressing the Muslims, the hard line Hindutva which is going on in the country, those type of Hindus get this, what we can say, appeased. Okay, so he will not never tell that, because why will he get the tag of anti-national? Because speaking the truth nowadays is equal to anti-national according to the government which is ruling. So he will never tell all those things that Article 370 had religious polarization associated with it. Those things he will never tell. He will only discuss the matter. He will only discuss the matter according to examination perspective. So if you want to clear IAS exam, na, his videos are very good. His videos will help you very much for IAS exam. But never consider that his videos are based on truth. Never consider that his videos are based on truth. Although he tries to legitimize his lecture and says that I am telling the truth, but he tells only half the truth. For example, if we say that why the Allahabad city of Allahabad name was changed to Prayagraj, okay, so an IS officer can never say that it was because Yogi ji wanted to communalize the Hindus. He wanted to religiously polarize the India, the UP. Okay, no one will tell that. No civil services teacher will take such a big risk of talking against someone. Okay, because he will be very much afraid. So everyone will just say that just mug it up that if people's sentiments are associated with it, then it is okay. Okay, like that you can say. So such things are there. So such restrictions are there on IS officers and the civil services teachers. So never consider that because Divyakirti sir is telling the truth, and this is the truth, and people are unnecessarily afraid. Never tell like that. Never think like that. People are not unnecessarily afraid. People are in reality afraid because if you try to look from truth perspective, na, then it will become clear. According to Vikas sir, it is from the examination perspective which we have to mug up. So you can use Vikas Divyakirti sir for the examination purpose, but never consider that it is truth. Okay, never consider that it is truth. So Maxwell Boltzmann distribution. Consider a system of n weakly interacting particles governed by the same Hamiltonian H. So a system of n weakly interacting particles are there. They are governed by the same Hamiltonian, which is capital H. Okay. So this you will eventually get clarity about this in the quantum mechanics. When you study the quantum mechanics, this will become very clear to you that consider a system of n weakly interacting particles governed by the same Hamiltonian H. This will become very clear to you after you study the quantum mechanics, which I haven't taught yet. And you will have to basically go to the advanced physics channel and learn it from there. Okay. So this is basically ensemble hypothesis. It is this statement. Consider a system of n weakly interacting particles governed by same Hamiltonian H. This is based on your ensemble hypothesis. Okay. Now the ensemble hypothesis, I will give you a homework that study the ensemble hypothesis. Okay. Ensemble hypothesis. Just a short homework. Although it is not in your syllabus. Ensemble hypothesis. Okay, so ensemble hypothesis you should study from the Google. Ensemble means guchha. Okay, we call it guchha in Hindi. Guchha. So this ensemble hypothesis you will have to study from the Google. So Maxwell Boltzmann distribution. Now consider a system of n weakly interacting. Now why we have taken the weakly interacting particles? Because if we do not take the weakly interacting particles, then each particle will affect the another particle, and in that case the distribution function will be very different. Okay, if every particle attracts or repels any other particle, then it will be a difficult interaction. Okay, so in order to simplify our interaction governed by the same Hamiltonian H, so that's why we are taking weakly interacting particles so that they can be governed by the same Hamiltonian H. Okay. Also let n1, n2 up to nn be the number of particles with energies e1, e2, e3, e4, so on and so forth up to en. Okay. So see over here. I am telling you. Now suppose this is your state number 1. Degeneracy is g1, number of particles is n1, and energy level is e1. Okay. Because Divakirti sir had once said the truth on his website. Okay, so what happens is that many people did his lynching, social media lynching. Okay, so everyone is at risk nowadays. Okay, so G1, N1, E1. This is your state number 1. Then your state number 2, maybe whatever may be the degeneracy. Okay, degeneracy whatever it may be. Then G2 is the degeneracy over here, N2 is the number of particles over here, and E2 is the energy level. Similarly, so on and so forth. So on and so forth up to here. Up to here, Gn, Nn, okay, Gn, Nn, and En. Okay, so this is the your last energy level, comprising of capital and small n particles, and Gn is its degeneracy. So such is the situation. Okay, quantum states G1, G2, G3, G4 means that it is basically your degeneracy. Okay, it is what? It is your degeneracy. So Gi is known as degeneracy of the energy level Ei. Okay, Gi is known as the degeneracy of the energy level Ei. The ensemble of these degenerate states is called microcanonical ensemble. Ensembles are of 3 types. If you study from Google search the ensemble hypothesis, then there are basically 3 types of ensembles, which I am not remembering the names of those 3 types of ensembles. But amongst those 3 types of ensembles, one of the type is microcanonical ensemble. Okay, one of the type is like this. The degree of degeneracy of a level is called its statistical weight. Now, the degree of degeneracy of a level, for example, degree of degeneracy of this level, first level is G1. So degree of degeneracy is G1. Then degree of degeneracy for the second level is G2. Okay, degree of degeneracy for this nth level is Gn. Okay, so what is this? The degree of degeneracy of level is called its statistical weight. Okay, so it has basically your first level has statistical weight G1. Okay, your second level as its degeneracy is G2, so its statistical weight is G2. Okay, then your third energy level, its statistical weight is G3, right? So on and so forth. Okay, now occupation probability f of ei is equal to your ni divided by gi. Now what is meant by this? Now we will understand the meaning of this. Then what does it mean by occupation probability? Okay, we will learn this. So just look over here. For example, suppose I have ni particles in the ith level. Okay, I have ni particles in the ith level. Then gi will be its degeneracy, and its energy level will be basically your ei. Okay, for example, this is 1, this is 2, so then 3 will come, then 4 will come, then I will come, then n will come finally. Okay, so in the ith energy level, suppose this is the degeneracy. Okay, and degeneracy is suppose 5 is the degeneracy suppose, and ni is your number of particles, total number of particles. Then you will distribute these ni particles in these 5 states. Okay, so what will be the average number of particles in each state? What will be this is gi equal to 5, right? So what is the number of particles in each of the states? Average number of particles, that will be ni divided by gi. Okay, clearly ni divided by 5 over here, that is ni divided by gi clearly. Okay, so your occupation probability, that average number of particles per quantum state, that will be your equal to occupation probability. Okay, that will be equal to your occupation probability. So f of ei equal to ni divided by gi. Why it will be equal to occupation probability? Because when you take the average, okay, for example, when you say that the dice has 6 faces, it is a cubical dice, it has 6 faces. it has 6 faces. So what is the probability of 1 coming out? 1 by 6. What is the probability of 2 coming out? It will be 1 by 6. What is the probability of 3 coming out? 3 by 6. What is the probability of 4 coming out? 4 by 6. 1 by 6. Okay, all have 1 by 6 probability. 1 has 1 by 6, 2 has 1 by 6, 3 has 1 by 6, 4 has 1 by 6, 5 has 1 by 6, and 6 also has 1 by 6 probability of coming over the top. Okay. Now, similarly, consider this thing, that occupation probability. Now, number of 6 on the dice were 1. That's why 1 over 6 was the probability. Now, over here, the total number of states is Gi. Gi is the total number of containers, and Ni is the total number of particles. So, occupation probability, what will it be equal to? It will be equal to your clearly average, because you will divide by the total number of containers in order to find the occupation probability of each container. By principle of equal or priori probability, you consider that Ni particles are situated in those containers in such a manner that each container occupies the same number. Each container has the same probability of occupying the particles. So as each container has the same capacity, so average will be equal to your occupation probability. So Ni divided by Gi will be equal to your f of Ei. So if energy levels are very close, then what will happen? If energy levels are very close, then these energy levels will become continuous. Suppose your energy levels are like this, but if I bring them very close, so if they keep on coming closer, then what will happen? It will become a continuum. It will become a continuum because very close energy levels. So it will become what? It will become a continuum. Very close energy levels means it will become a continuous distribution. Okay. So your EI, when it comes very much near, for example, these are separated, but they come very near, then what happens? The situation of this kind arises. Okay. So in that case, in the case of continuous distribution, what happens is that we replace the subscript I by simply f of e. So that is your distribution function. Now calculation of f of e. We will do in the next class. Okay. Yes. So let us continue from where we had left in the last class. Oh, so this is taking a lot of time to start. So calculation of f of e. Okay, f of e means distribution function, continuous distribution function. So as the particles are distinguishable, I had already told you this in the previous class, that when the particles are distinguishable, so the number of ways in which the groups of n1, n2 and so on and nn particles can be chosen from n particles is given by. Okay. So as the particles are distinguishable, so it is given by this I had already derived in the previous class. The laptop is lagging a little bit. Okay. So this I had already told you in the previous class. Okay. I had derived this in the previous class. Now consider the Ni particles selected for the energy Ei. Okay. We have to consider the Ni particles which have been selected for energy level Ei. These are to be distributed in Gi quantum state, because I already told you that N1 number of particles are there in E1 level and its degeneracy is G1. Then N2 particles are there in E2 level and its degeneracy is G2. N3 particles are in E3 level, its degeneracy is G3. Okay. So like that. So these are to be distributed in the Gi quantum states. Since each particle can be put in Gi ways, okay, Gi ways, obviously if there are Gi containers, Gi degeneracy means Gi number of containers will be there. So each particle can be put in Gi ways, right? So first particle can be put in Gi ways, then second particle can be put in Gi ways, third particle can be put in Gi ways, fourth particle can be put in Gi ways, and so on and so forth. Nth particle can also be put in Gi ways. So Gi into Gi into Gi into Gi, how many times? Ni times. Ni number of times will be there. Okay. So there are Gi to the power Ni ways of putting Ni particles in Gi states. Okay. So there are in total Gi to the power Ni ways of putting Ni particles in Gi states. Right. Now it is taking a little bit time today. I don't know why it is lagging. Okay. Considering the different values of I, the total number of arrangements will be like this. That if you take the different values for G1, degeneracy and N1 number of particles, this will be the thing. Then for G2 number of G2 and second energy level, G2 will be the degeneracy and N2 will be the number of particles. Then G3 will be the degeneracy for the third level and N3 will be the number of particles for E3 level. Okay, this is for your E1 level. Okay, this is for your E1 level, this is for your E2 level. Okay, and this is for your E3 level, right? Then similarly for E4th level, what will be the thing? This will be for E4, and so on and so forth. It will go on up to EI level. EI level. Okay, it will go on up to EI level. So GI to the power NI will be the final thing. Okay, for EI. So if you take the product of all these up to GI to the power NI, okay, you can represent it like this, that I is varying from 1 to I. Okay, I is varying from 1 to I, and this is the thing. So you can represent it like this, because probability is multiplicative in nature, not additive in nature. Someone may ask that why over here plus is not there, why there is multiplication. Someone may ask like this. So the thing is that there cannot be addition over here, because probability is always multiplicative in nature. Okay, so as probability is always multiplicative in nature, in permutation and combination in the 11th class during the time of JEE, you must have learned this thing, that all the uh, possible number of arrangements are in multiplicative nature. They are of multiplicative nature, not of additive nature. Okay, so this will be of additive nature, multiplicative nature. Then the next slide is taking a time to load. Okay, so hence the total number of microstates corresponding to the macrostates. Okay, n1 and 2 for these macrostates, the total number of microstates or the thermodynamic probability for the most probable macrostate will be given like this. Okay, so total number of microstates or thermodynamic probability. Okay, so total whatever will be the total number of microstates, that will be the that will be the most probable macrostate. Okay, for example, you took W1 into W2. What is your W1? Let's see over here. What is your W1? Let's see. The laptop is little bit lagging today. Okay, so W1 is like this, right? And your W2 is like this. Okay, so this basically represents your the thermodynamical probability. Why? Because when you take the product of these two, you will basically get the value of W. Okay, you will basically get the value of W, and your W is related to the thermodynamic probability. This will become eventually clear. Okay, this will become more and more clearer to you. Okay, so macrostates corresponding to macrostates, these corresponding to these macrostates, the total number of macrostates will be given in this manner, and the thermodynamic probability for the most probable macrostate. Okay, so because the total number of outcomes is 1 over here, in the denominator there will be 1, right? So it is basically thermodynamic probability of most probable macrostate. Okay, so this is the thing, because in the denominator there will be 1, right? Because 1 is the total number of ways. 1 means that all the states are filled. Okay, 1 means all the states are filled, and if total number of states are over here, then it will be the probability of having most probable macrostate filled. Okay, most probable macrostate means most probable macrostates. Let's see over here. See, so over here from E1 to EI are the energy levels, right? From E1 till EI are the energy levels. So for the most probable, somewhere in the middle there will be the most probable state. Okay, so if you apply common sense, the most probable state will be like this, right? Might be ranging from E1 up to EI. Okay, so if you try to find out the probability of the most probable state now, that is also going to be the same. Okay, it is going to be equal to this W1 into W2. Okay, so this is the thing. So it is basically this, your W comes out to be this finally. So let this be equation number 3. Now take natural logarithm. Take like natural logarithm on both the sides. You get something of this kind. How did you get this? When you take the logarithm, these are in multiplication and this is in division. So this will become ln n factorial plus ln. Okay, product I gi ni. Okay, so this will be gi to the power ni. So power ni will come in the front. Okay, power ni will come in the front, and this will go in the denominator. So denominator thing will come in the form of minus ln. So after you do that manipulation, this is the thing which you get. Taking natural logarithm, we get. Okay, this is the thing which you get. Then from Stirling formula, what do you get from Stirling formula? Ln x factorial equal to x ln x minus x. Okay, so when you take x common from here, x into ln x minus 1 for large value of x. Okay, for large value of x. This is the thing for this approximation holds. This Stirling formula holds for large value of x. Okay, so you will apply over here this formula. So after you apply that formula over there, you can pause the screen and take this. You can write the notes along with me. Then ln w will be equal to like this. Okay, these are all mathematical manipulations. I will recommend to just you must just download these and look at the mathematical manipulations. There is nothing big in it. When you open the bracket, this into this will happen, this into this will happen. Okay, then this into this will happen, means this and this will become plus. Then you apply this formula. Why this formula came? Because summation I and I will be equal to total number of particles, which is capital N. Okay, because E1 state contains N1 particle, E2 state contains N2 particles, E3 state contains N3 particles, E4 state contains N4 particles, E5 state contains N5 particles. Okay, so EIth state contains Ni particles. If you add all the i's, means N1 plus N2 plus N3 plus N4 up to Ni. Okay, if you add all this, then you get basically capital N. Capital N is your what? Capital N is your total number of particles. Okay, so this is the thing which you get. Then for the most probable state, we apply the maxima condition, and when we apply the maxima condition on this function w, then what happens is that we get the most probable state. Okay, because see, when w will be maximum, your d of ln w will also be maximum, right? When w is maximum, your ln w will also be maximum, because you have found out ln w over here. Okay, over here what you have found out? You have found out ln w, and if you try to take the maxima of ln w, then how will you take it? When w will be maximum, that is the probability of occurrence of a particle in particular most probable state. W is basically your probability of the probability of the most possible macro state. Okay, W is what? Probability of most possible macro state. So when most probable state W, its probability will be maximum, then W will be maximum. So W will be maximum, then ln W will be maximum. So as the maxima has its differential equal to 0. You must have learnt in 11th standard in maxima and minima that maxima and minima have differential equal to 0. So over here, this is the maximum condition. Maxima is there in the W. So when W will be maximum, ln W will be maximum, and its differential will come out to be 0. So its differential is equal to 0. Then you basically take the differential of all the terms. Okay. So whatever the expression you got over here, okay, whatever expression you got over here, just apply differential on both the sides on this expression. Apply differential. Okay. Apply differential over here. Differential this much. Okay. So after you apply the differential, you will eventually find the things. Okay. Let's see over here. Okay. See, summation this you will get, summation this you will get. Okay. This is all common sense. Okay. This is all common sense. You have to just copy down it in the notebook and just write it down in the notebook, and you will understand everything, each and every step. Okay. So summation ln gi, this and these are there. So these are just mathematical manipulations, nothing else. Okay. Then this is the thing. Then you know this very well that Ni is the number of particles. Number of particles will be very large in real life. In real life, the number of particles will be of the order of. In real life, the number of particles will be of the order of 10 to the power 23. Right? Number of particles will be of the order of 10 to the power 23. So when you try to take its log, that is also going to be a huge number. Log will also be a huge number. Then as the log will also be a huge number, so this ln ni will be a huge number as compared to this 1. So 1 can be neglected in front of ln ni. So 1 is neglected over here, and you got the equation number 4. You neglected this 1. Okay. As the total number of particles is fixed, so this is your fixed, right? N1 plus N2 plus N3, this is fixed. So dni, this will be your 0, right? Because differential constant of a differential of a constant is 0. Okay, differential of a constant is 0, so this will be 0. This is your equation number 5. So as the system is isolated, so its total energy, how will it be given? As the system is isolated, so its total energy is given like this, that you take the summation of ni ei, which is equal to your constant. Okay, because total energy will be constant for an isolated system. What does it mean by isolated system? Isolated system means neither the matter is transferred nor the energy is transferred. For an isolated system, neither the matter is transferred nor the energy is transferred. So in such a system, the total energy will be constant, and total energy will be given like this. This is common sense because E1 state contains N1 particles. Okay, E2 state contains N2 particles. E3 state E3 state contains N3 particles. E4 state contains N4 particles. E5 state contains N5 particles. So if you try to add all the energies, then it will be simply N1 E1 plus N2 E2 plus N3 E3 plus N4 E4, like that. Okay, it will be like that. So total energy will be given like this, which will be equal to your constant. Okay, because the system is isolated, so it will be a constant. So du will also be your 0. Okay, now this expression will come after you take du equal to 0, because u is your constant, so differential of u will be equal to your 0. Now the the energy, okay, let's see over here. Okay, when you try to take the differential over here like this, okay, then what will happen? Your energies will be constant, right? Even energy level will be will have constant energy. E2 energy level will have constant energy. The energy levels will not change, right? Energy levels, why will they change? Only the particle configuration will change. Okay, suppose this is E1 energy level, this is E2, this is E3, this is E4. So these energy levels will remain fixed, because in hydrogen atom also you must have seen this thing, that the first energy level of the first orbit is constant, energy level of the second orbit is constant, third orbit is constant. So E1, E2, E3, these will remain your constant. Okay, why will they change? Because the temperature is fixed, so they will not change. Temperature is fixed, right? So they will not change. So only the Ni will change, means distribution will change, means this N1, N2, N3, N4, these can change. Okay, so eventually what do you get? So eventually you get summation I ei d n I equal to 0. So multiply equation 5 by alpha. What is your equation number 5? This equation. Okay, equation 5 you just multiply by alpha, and just a second. Okay, and equation 6 by beta. You multiply it by beta, and add them with equation number 4. What is your equation number 4? Let's see. Okay, this is your equation number 4. Add them with this equation number 4. Okay, so what do you get? Let's see. We get something of this kind. These are just many mathematical manipulations, nothing else. Okay, you get something of this kind. Since the variations are quite arbitrary, we write. Okay, what are the variations? Variations are quite arbitrary, right? Means variations are quite arbitrary just means that your this summation of all these things. Okay, when you try to put the values and find out the sum, then you will find that this d and I, okay, differential of this Ni will not be equal to 0. Why differential Ni will not be equal to 0? Because Ni, that is the number of particles in each state, number of particles in each energy level is changing. Okay, so variations are quite arbitrary because number of particles in each state are changing. So dni will change. So dni, as ni is not a constant, so that's why your dni will be equal to not equal to 0. Okay, so this term is not equal to 0. So but this on the RHS of this equation there is 0, but dni is not 0. So eventually this term must be 0. Okay, so this term has come out to be equal to your 0. So from here you can clearly see this thing, that ln ni by gi, okay, equal to alpha plus beta ei. Then you will apply the logarithm property. Okay, then you will apply the logarithm property and you will get like this. Then eventually e to the power alpha you will separate out from here. You can write this as e to the power alpha, e to the power beta ei. Okay, then e to the power alpha can be written as a. Okay, so this is the thing, where a equal to e to the power alpha and f of ei is the occupation probability at the energy ei. Okay, f of ei is the occupation probability at energy ei. So the constant beta equal to minus 1 over kt. Okay, k equal to Boltzmann constant. Okay, this is the thing. This is quite this na. Your beta equal to 1 upon kt. You have already assumed it in the previous thing. No, not assumed, but the constant beta comes out to be equal to like this. Okay, comes out beta the thing which is the constant beta, it comes out to be like this, minus 1 upon kt. Okay, so k equal to Boltzmann constant. Okay, your beta comes out to be like this. You will have to just remember this thing, that beta comes out to be equal to your 1 over kt. It will be a temperature dependent term. Why will it be temperature dependent term? because your energy levels EI are temperature dependent. Okay, so as EI is temperature dependent, but you have taken temperature constant over here, but even then, if we take the temperature into account, then your beta is coming out to be equal to like this, minus 1 over kT. Your K is your Boltzmann constant. So f of EI will be equal to your like this. In the place of beta, you will just substitute minus 1 over kT. Okay, then what happens? As the energy levels are almost continuous, so equation A is written as. So how do we write the equation number A? The energy levels are almost continuous, so we write the equation number A like this. Okay, equation A like this. So energy levels are almost continuous, na? That's why you have dropped the subscript EI. Okay, EI subscript is written when the energy levels are discrete. I subscript is written when the energy levels are discrete. But over here the energy levels are continuous, so equation A can be written like this. Now f of E is your Maxwell Boltzmann distribution function. Okay, so this is the thing. So this is all about Maxwell Boltzmann distribution function. Okay, so you must remember this in your mind, and believe me, if you just follow each and every step by noting it down in your notebook. Okay, note everything down in your notebook. See, I am telling you, note everything down in your notebook. Okay, note everything in your notebook. Okay, note everything in your notebook. Do not watch the videos idly. Okay, do not watch the videos idly, just sitting like that without empty-handed. You are seeing the videos. That will not benefit you at all. That is not going to benefit you at all. You will have to make the notes also side by side. Only then you can understand everything. Okay, only then you will be able to understand everything. And each and every mathematical steps which I have written over here, each and every mathematical step which I have written over here, that is self-explanatory. Don't ask me to explain the maths over here, maths involved over here. What are the maths involved over here? The maths involved is that log a minus log b. Then you must have explained this. Those things I will not explain. Okay, those are very simple mathematics. Okay, everyone will understand it. Okay, some chemistry optional people have a problem in maths. So when I teach chemistry optional, there I teach each and every mathematical step. But you are physics optional student, so you have the maths background already with you. As you are physics optional student, you already have maths background with you. So you must find all these mathematical steps to be very easy actually. Okay, these mathematical steps are to be explained to a chemistry optional person. He needs to if he or she is from background, then he or she may find it very difficult to understand the mathematical steps. So for them I teach the mathematical steps, but these are obvious mathematical steps, right? Ln gi by ni will be log a minus log b property. This will go over here and minus sign will come, then minus sign will cancel out. These mathematical steps are very easy. Okay, so everyone can surely understand this. So thank you very much, and please do subscribe to our channel if you like the videos, and you can explore the channel also for more videos. Okay.